Okay, I'm going to show you how to graph basic rational functions, and let's get started. So our vertical asymptote is always going to be the x value that makes the denominator 0. If we have 0 in the denominator, we have an undefined equation, or undefined function. So if you think about this, you could take x plus 3 and set it equal to 0 and think that x equals negative 3 would make this 0. And like I said, 1 over 0 is undefined, so that's why we end up having a limit on our x's. Now, a vertical asymptote is a line that goes up and down. It's vertical, and it acts as a boundary line. And it also relates to our domain. This is going to be all reals except x equals negative 3. So what that's really mean is that I can use all other values of x except negative 3. Negative 3 creates this situation where we have an undefined function. Okay, so the same token, your y, or your horizontal asymptote, all right, is y equals 0 in this case. Think about this. If this is impossible to make this 0, okay, down at the bottom, we can't make that 0. It's always going to be a number. If I plug in anything other than negative 3, you're always going to have a number. So you're going to have 1 divided by a number, and 1 divided by a number is always another number. It's never equal to 0. So just think about that for a second. So this is going to be all reals except y equals 0. So we have that all figured out. We know where the asymptotes are, so we're going to draw those as dashed lines. So at x equals negative 3, which is right here, we have a vertical asymptote, and this might be tough to do on your paper, but we know that that line is also, that's where y equals 0, which is really the x-axis. There's an asymptote there. So this graph is never going to cross those boundary lines. All right. So how do I get my points to plot? Like we always have, an XY chart. So move this down here a little bit. And I like to make two different XY charts because I'm going to have a few points on the right side of the boundary line that I want to try, like negative 2, negative 1, and 0. And then I'm also going to have a couple on the other side, like negative 4, negative 5, and negative 6. So usually if you pick a couple to the right of it, a couple to the left, right next to the boundary line, it works out the best. So now you could manually plug those in and see what you get, but just for time's sake, I'm going to use a graphing calculator. I just plugged it in to the y equals, press second table, and it's going to give me the table. So I'm just going to write these down quick. I get negative 1, negative 0.5, and 0.3 repeating, or 1/3. Okay, if you're checking your work, negative 4, 1, negative 5, 0.5, and negative 6 is. So you see that these sign. The only thing that's different is the sign. And that happens with some of these if you have a pretty basic equation like this. All right, so we're just going to plot those points quick. And once you do a few of these, you're going to know that the nature of this graph is to get really, really close to this line but never equal to this line. So when you're graphing it, just make it get closer and closer. Because if we look at this and we look at 8, all right, 8 is getting closer. You know, if we keep going down, it's getting closer and closer to 0, but it's never going to actually equal 0. So even all the way out at 42, it's not quite to 0, but it's pretty close to 0. Okay, this one, same thing. I'm expecting this to be off the boundary line a little bit, but then pretty quickly it's approaching 0. That's the first one. Number 2 is very similar. Vertical asymptote, x equals 2, because 2 minus 2 is 0. We can't have 0 on the bottom. Our horizontal asymptote is y equals 0. Now there's another way you can look at this. We have a basic form of a rational, and your horizontal asymptote is always going to be y equals k. Now in this case, we don't have a k or a constant term out there. It's actually 0. So you can look at it that way also. So the domain is all reals except x equals 2. It's very important that you write this as x equals 2. You don't just say all reals except 2. Same thing up here. Don't say the vertical asymptote is just 2. It's x equals 2 because it's a